Hi, I'm Carrie Morton, and we're here at Mcity, back again with Greg McGuire, our lab director. If you think about an automated vehicle, it's kind of like a human, right? We have 5 senses to sense the world around us. Well, an automated vehicle has a number of sensors to sense the world around it. So Greg's going to give us a little tour here on our open automated vehicle here in Mcity.
Hey, thanks, Carrie.
Thanks, Greg.
Sure. So, this is underneath a regular stock Lincoln. It's been modified by some of the Mcity members and our partners to actually be able to drive via software. We've added a whole bunch of sensors. Now, you might say, well, this is not the most nice looking system. I kind of think it is.
Greg,
as an
I
engineer.
refer to this car as the Swiss Army knife of automation.
That's right. But what it is very versatile. So we can bolt new sensors on that we want to test. We can move positions of things around. We can test different placement, different techniques, different types of sensors very quickly.
So what's this going to do for us, Greg?
Yeah.
For example, what is this sensor here? And
so that's a long-range radar, and so that's using radio frequency, high frequency, sending out a beam pulse, and then it's measuring, the reflection off of things. Obviously, metallic things reflect very strongly. Your legs, my legs, a little less strongly.
Can it see through rain and fog?
Yes, it can. So you can get a good glimpse of what's ahead on the road, obstacles and things, even in those weather conditions. I guess I point out usually that the general technique of these systems, because what we don't have today are human brains in the trunk of the car. We don't have that kind of computational power yet.
That's right.
So we have to make up for that with better sensors really than humans have. And to be able to do a lot more perception. And a variety,
exactly. It looks like.
So some of those sensors actually are radio sensors. We can communicate with this vehicle to the traffic lights and things behind us.
So connected vehicle technology.
Connected vehicle technology, exactly.
Terrific.
That's a sensor, right? Because
I like to say, Greg, that's like giving the automated vehicle ESP or sixth sense.
A sixth sense, yeah. I totally agree with you.
Okay.
Yeah. So these are something called LiDAR. This is an infrared laser, and it's actually this one I think's got four individual beams, laser beams that are aimed kind of low, and those are going out, and actually the reflection off of things like my pants, which is a fairly unreflective, but maybe a vehicle bumper or a traffic cone or something in front.
Maybe a pedestrian.
Absolutely. And it's measuring the speed of light. I mean, think about that for a second. You're measuring the speed of light at a few feet. It's quite fast. It's amazing to me that we can do that, but we can. And it's using that to actually figure out distance. So how far away is that thing? That's a great sensor. We do that with our stereo vision, and then our brain can figure out, because of the shift. We can perceive depth, but we're actually assuming depth. So we can, you can do all kinds of optical illusions to trick your brain into thinking things are far away or close, depending on that. This is actually getting depth based on an actual reflection of light and the speed that it takes. So it's harder to fool that.
So a lot of great information coming in. It's just, again, comes back to having the brain that can put all that together or fuse that together. So speaking of stereo vision, tell me a little bit about this
one
guy
here?
Glued up under the dash.
Yeah, that's a camera from a company called Mobileye, which is part of Intel, one of our member companies. And that is actually using a regular color video camera, just like what we're shooting this lecture on now. But they're applying some very intelligent software to it to figure out what in the frame it's looking at. So it can do things like figure out that's a person probably standing there, or that's a lane line on the road, or that's a vehicle or a truck. And it can tell then, it can feed into our computer system information about that object. So it can say, that's a truck and it's moving in this direction at this speed. So it can add a lot of interesting knowledge to what it's seeing in the camera, all by itself, and then send that on.
So does this work in inclement weather or, let's say, in nighttime conditions, Greg?
Well, it really depends on the capabilities of the camera. In this case, this camera, no. It can be occluded by snow and fog in the same way that our eyes can. It doesn't work very well at night, given the same as our eyes, right? But if you illuminate the environment in front of it with lighting, or you change out this particular camera for
Sure.
one that's good at seeing in the dark, you can avoid those kinds of constraints. Yeah.
So what about this guy on top? This is like a really fancy puck.
Yeah, that's
Tell
a
us
very,
about this LiDAR.
very expensive LiDAR. So this one is just like the ones on the front, except it's got a lot more beams. So it can see, that vertical resolution. Think back to the old green monitors of the 80s.
Ooh, Apple IIe.
Exactly.
Yeah.
Where you could see the lines on the screen. I mean, this is where kind of that stage with these systems, but increasing very quickly. So but the interesting thing about this one is it actually rotates on a mechanical motor that can let it see 360 degrees around and out a couple hundred yards. It can see a few football fields of distance away. You really need that if this vehicle's traveling at highway speeds. A few hundred yards gets here very
Right.
quickly. So
Right.
you want to be able to see far ahead to be confident you can move it at speeds that we're used to on our highway.
Right.
Yeah.
Okay, what about, there's some antennas on the back.
Yeah, so we have a whole plethora of antennas, right? We're like somebody's amateur radio operator here. These two in the center here, these are GPS antennas. So of course overhead we've got a few dozen satellites that are orbiting the Earth, and we can use the signals from those satellites to triangulate our position and our altitude. The two antennas, this system is actually so precise, it's down to less than an inch of accuracy on the ground. So by having two antennas on the vehicle, we can actually use that to determine the direction that the vehicle is pointing to a very high degree of accuracy, which is kind of amazing to me. These things are a few hundred miles overhead.
So compare that to what is in my typical smartphone or even in my current vehicle today, which sometimes tells me I'm arriving at my next door neighbor's house and not my house. So
yeah, there's a couple things going on there. So, your phone is accurate to maybe 10 to 20 feet. Probably not good enough for using that alone to navigate a vehicle, right? 10 or
Right.
20 feet is maybe that lane or this lane, I'm not really sure. Well, that matters a lot if that's the oncoming traffic lane. The other thing, though, that happens is that signal that's coming down from space can bounce around a little bit. It can bounce off of buildings, can reflect in weird ways. And so if you're used to taking an Uber or Lyft or something in a city and you find that it's picking up on the wrong side, that is because of something called multipath. You're getting this GPS signal scattering, and that measurement of time that it's doing is so precise that if that path bounces and travels a little extra distance on its way to you, then your calculation is off. So these are the kinds of things. We can't test multipath in our test facility very well, but we can do a couple of other interesting things to simulate those environments.
Okay.
We have a tunnel down to my right, which actually absorbs the satellite signal as you drive through, like a tunnel would. You can't see the sky anymore, so you can't hear those satellites. How do you deal with a loss of your position? And then in the spring, summer, and fall, we have a canopy that we can raise up to the north end of this facility that actually mimics the foliage, that's on trees in a neighborhood. If you're driving through the neighborhood, and those trees will absorb some of that signal. So you can test a degradation or a complete dropout in here, which is just like you'll find in the real world, as you say.
So on a vehicle like this, Greg, you really have a unique asset because it's flexible in terms of the different types of sensors we can test, and you can again look at the fusion of all of those
Yes.
to not only see the world around us and avoid obstacles, hopefully,
Yep.
but also to know where we are in the world. They're both really important elements of the sensor technology represented here today on this vehicle.
Yes, that's exactly right. And I would point out that the brains or the software that we're using in this vehicle is based on an open source software stack. Open source means the source code that actually goes into the compiled software that runs in this vehicle is open and available. It's published on the internet. We use it here. Many other research teams in other parts of the world use it. The nice thing for us is we can build research projects on top of it. and we can redistribute that source code to other research teams to improve upon and publish their own papers with.
So it's essentially like you're part of a virtual global team
Absolutely.
tackling these challenges.
We absolutely are.
Terrific.
Yeah.
Terrific. Well,
Nice.
thanks very much, Greg.
Okay.
And thank you for joining us, and looking forward to having you join us further in the teach out. Thank you.
Thanks.